Okay students, for example 16c, sin theta equals to negative square root of 3 over 2. Now it's really important that we know this is a negative value. A negative value shows that theta does not fall on the first and the second quadrant, whereas the first theta is on the third quadrant, because this is tangent and sine negative will fall on the third and the fourth quadrant. Okay, because sine is negative. Okay, tangent and cos, it falls on the tangent and cos. That's number 1. Number 2, we need to know where is our angle. So we're going to start from positive x-axis and we're going to draw the angle until the terminal line for both the example. Okay, for both the quadrant. Okay, so once we have drawn this is the theta. Okay, from theta, okay, from this we should know where is alpha. For the first angle that falls on the third quadrant, reference angle will be the angle attached to x-axis and less than 90 degree. So the shaded area here belongs to alpha. Okay, now for the second angle which falls on the fourth quadrant, okay, reference angle is attached to x-axis and less than 90 degree. So this is alpha. Okay students, now to find alpha, we can eliminate the negative sign. Negative sign is just to decide which quadrant does theta belongs to. Okay, so what is arc sine of square root 3 over 2? So you have to press your calculator. So arc sine of square root of 3 over 2 will be giving us 60 degree. Remember, this is alpha, not theta. Now for the first theta that falls on the third quadrant, okay, from the x-axis until 180 degree, okay, we're going to take the 180 degree and we're going to plus with alpha here, okay, which is 60 degree. So theta is 240 degree. Now for the angle on the fourth quadrant, okay, we're going to take the whole 360 degree, we're going to minus with 60 degree, and this will be giving us the answer 300 degree. Okay, for question number 16c, we have two angles 240 and 300. Okay students, I hope you are following this. Next we're going to try example 16d, tangent theta equals to negative 2. The method is the same. Okay, first what we're going to do, we're going to decide which quadrant does tangent theta negative 2 belongs to. So it's all depends on the sign here. So if this is a negative sign, which means we have angle on the quadrant that doesn't belong to tangent and doesn't belong to the all quadrant. Okay, so for all quadrant it has to be positive. So now we will have angle at sine and cos. So sine is the second quadrant, cos is the fourth quadrant. For the second quadrant, okay, we're going to start from positive x-axis anti-clockwise until we reach the second quadrant, and we're going to draw our terminal line. So this is theta. Okay students, now from theta we can already decide alpha. Alpha is also attached to x-axis to the terminal line less than 90 degree. So this is going to be alpha, which is reference angle. Next we look at the fourth quadrant. Next we look at the fourth quadrant. So we're going to start with x positive and we're going to draw anti-clockwise until we reach the fourth quadrant, and we're going to draw the terminal line. So this whole thing is theta, and the reference angle would be the angle less than 90 degree attached to x-axis to the terminal line. So that's going to be alpha, the reference angle. So we find reference angle first. To find reference angle, we do not have to consider the sign, positive or negative. So arc tangent of 2, you have to use your calculator. So we will be getting 63.4 degree. Okay, that is for reference angle. Now our aim is to find theta. So for the second quadrant, it would be 180 minus 63.4 degree, which will give us 116.6 degree. So this is for the angle on the second quadrant. Now we're going to find angle on the fourth quadrant. So to find theta, we're going to take 360 degree minus alpha, which is 63.4 degree. So we will be getting 296.6 degree. So we have two answers, 160.6 and 296.6 degree. Okay, students. Okay. So it's very important that we find out which quadrant our angle falls on, and also find the reference angle, and followed by find the angle that we are interested in.